let's say that we have a bunch of masses. Let's say that we have a bunch of masses. Actually, let's not do it with masses. Let's just do it with forces because I want to complicate the issue. So this is the pivot. And let's say I have a force here that's 10 newtons going in the clockwise direction. And let's say it is at, let's say if this is 0, let's say that this is at -8. So this distance is 8, right? Let's say that I have another force going down at 5 newtons. And let's say that its x-coordinate is, I don't know, -6. And let's say I have another force that's going up here, and let's say that it is 50 newtons. This might get complicated, 50 newtons, and it's at -2. So it's this distance right here is 2, right? And let's say that I need to figure out, let's say that I'm making this up on the fly. Let's say that I have another force here that is 5 newtons. No, let's make it a weird number, 6 newtons. And this distance right here is 3 meters. And let's say that I need to figure out what force I need to apply here, upwards or downwards. I actually don't know because I'm doing this on the fly, to make sure that this whole thing doesn't rotate, right? So to make sure this whole thing doesn't rotate, essentially what we have to say is that all of the counterclockwise forces, all of the counterclockwise moments, or all of the counterclockwise torques have to offset all of the clockwise torques. So what are all the, and notice they're not all on the same side. So what are all of the things that are acting in the counterclockwise direction? So counterclockwise is that way, right? So this is acting counterclockwise, this is acting counterclockwise, and that's it. Right? And so the other ones are clockwise. And we don't know this one. Let's assume for a second. Well, we can assume either way, and if we get a negative, that means it's the opposite. So let's assume that this is and so all of the clockwise ones I'll do in this dark brown. Let's assume this is clockwise. Let's assume that this is clockwise. And let's assume that our mystery force is also clockwise, right? So all the clockwise moments have to offset, all of the counterclockwise moments have to offset all of the clockwise moments. So what are the counterclockwise moments? Well, this one's counterclockwise, so it's 10 newtons. Moment arm, we said it's 8, right? Because it's the x-coordinate -8 from 0, so it's 10 times 8 plus 50, right? This is also counterclockwise times 6. 50 times 6. And those are all of our counterclockwise moments, and that has to equal the clockwise moments. The clockwise moments, let's see, we have 5 newtons that's going clockwise times 6. 5 newtons. Actually, was this 6? No, if this is 6, I must have written some other number here that I can't read now. How far did I say this was? I don't know, let's say that this is 2. So that 50 is, let's say that this is 2. It's -2, because that's what it looks like. I apologize for confusing you. So what were all the counterclockwise moments? This 10 newton times its distance, 8. The 50 newtons times its distance, 2. And don't get confused by the negative. I just kind of said we're in the x-coordinate axis, so we're at -8 if this is 0. But it's 8 units away, right? And this 50, its moment arm distance is 2 units. And so that has to equal all of the clockwise moments. So the clockwise moments is 5 newtons times 6, right? Its distance is 6, and it's 5 newtons going in the clockwise direction. And then we have plus 6 newtons times 3, plus 6 times 3. And then we're just assuming, we don't know for sure, our force, and let's say we're applying the force, I should have told you ahead of time so you can do this problem. Let's say that we're applying the force at 10 meters away from our fulcrum arm. So force times 10. So now let's just solve for the force. We get 80 plus 100 is equal to 30 plus 18 plus 10f. We get 180 is equal to 48 plus 10f. What's 180 minus 48? It's 132. So we get 132 is equal to 10f, or we get f is equal to 13.2 newtons. So if we apply, so we guessed correctly that this is going to be a clockwise. Sorry, this is going to be I keep mixing up all of the clockwise and counterclockwise, but idea that this is going to be a clockwise force, right? These were all of the, sorry, this is going to be a counterclockwise force, right? This is counterclockwise. So all of these, let me label that because I think I said it wrong several times in the video. So these go clockwise, and it's this one and this one. And what were the counterclockwise? These go counterclockwise. So we have to apply a 13.10 Newton force 10 meters away, which will generate 132 Newton meters moment in the counterclockwise direction, which will perfectly offset all of the other moments, and our lever will not move. Anyway, I might have confused you with all of the counterclockwise, clockwise, but just keep in mind that all the moments in one rotational direction have to offset all the moments in the other rotational direction, and all a moment is the force times the distance from the fulcrum arm. So force times distance from fulcrum arm. Force times distance fulcrum arm. I'll see you in the next video.